So our example 2 says we should balance the redox reaction in basic medium. So we shall proceed now to looking at how to balance that reaction in basic medium. So how do we go about that? Now we'll have to do so just as we have done in the previous example. That is to say, in balancing any given redox reaction, we have to first and foremost identify which of the species has been reduced and which has been oxidized. So that is actually what we need to do. So we shall proceed now to looking at how to do that. Looking at it first and foremost, we'll see that ion 2 has gone from ion 2 to ion 3, which means it has been oxidized. And the chromate there has gone from what it was before to chromate 3, because it's easily seen that that is chromate 3. Now the question is, what is the oxidation state of chromium in the reactant species side, Cr2O7 2-. What is the oxidation state of chromium there? For some students now, that may be a little challenging, but now we shall look at that so that you can always and always recall and know how to balance such reactions. So we have our chromate Cr2O7 2-. And I told you that when we have something like this, that is to say a radical with a charge, whether plus or minus, we have to equate it to that charge, -2, not 0. But when it's a compound like CaCO3 and you are asked to find the oxidation number of any of these atoms here, any of the elements here, then what you need to do is to just equate to 0. And then you can use the known to find the unknown. That is for compounds. But when it is a radical that has charge, then we equate everything to the charge it has. So in this case, chromium oxidation state ought to be calculated for. So we know that chromium, since chromium is unknown, is going to be 2 times Cr for chromium. Since it's chromium we're looking for, then plus oxygen is -2, but there are 7 oxygen atoms there. So it's going to be -2 times 7, and then everything equals to -2. So this is 2 chromium plus -2 times 7 is -14. That gives us -2. So this is going to give us 2 chromium minus 14 equals -2. And here we have 2 chromium equals 14. We'll go over there to become plus. And then we have 2 chromium to give us 12. And automatically chromium is 6. So you can see we are very correct when we say that chromium has been reduced while iron has been oxidized, because chromium in the previous compound has gone from chromium 6 to chromium 3. So it means the chromium has been reduced, but the iron has been oxidized. So that is actually how to know which species is reduced and which species is oxidized. Okay, so with that now, we proceed to carrying out our balancing of the equation. So we have it that chromium 2- in reaction with iron 2 gives us chromium 3+ and iron 3 . So all in aqueous solutions. So how do we go? We have seen iron is oxidation, chromium is reduction. So we can say our chromium now, this is step 1, we have identified. So the next step is step 2. We write out the half cell reactions. So to write out the half cell reaction, chromium has gone from chromium 6 to chromium 3. This is the reduction half cell reaction. That's the reduction half cell reaction. Reduction half cell reaction. So the next is iron. Iron 2 went from iron 2 to iron 3, and that is the oxidation half cell reaction. That is oxidation half cell reaction. So that is step 2. So from step 2, we go to our next step, step 3. We are going to balance other atoms other than oxygen and hydrogen. So any element that is not oxygen and hydrogen should be balanced at this next step. So let's proceed. So for the reduction half cell, who do we need to balance? Is chromium. We can see chromium is 2 at the left but 1 at the right. So how do we balance chromium? Somebody may make the mistake of putting 2 here. It is wrong. You always remember in our balancing of equations, that is under normal balancing of equations for inorganic reactions like acid and base, the common simple balancing of equation, we don't balance equations with subscripts. So if you put 2 as subscript to chromium, then it means you have done the wrong thing, dear students. So please avoid balancing equations using subscripts. We don't balance equations using, so whether in the normal balancing of equations or in balancing of redox reactions, we don't use subscripts. So we have to balance our chromium by adding 2 as a coefficient in front of chromium. So we can see now that we have balanced chromium. So let's look at iron. Iron is the oxidation half cell. We have 1 iron at the left, 1 iron at the right. Do we need to balance iron? No. It means iron doesn't need any balancing. It is very okay. But we've balanced chromium, who needs balancing. So that is step 3. Step 3 is done. So we'll move to the next step. Step 4. Step 4 says, now we move ahead to balance oxygen. Since we've balanced other atoms that aren't oxygen or hydrogen, now let's balance other, and let's now balance the oxygen atom. So at the left hand side, oxygen atom is 7, but at the right hand side, we don't have any oxygen atoms. So what do? It means we have to balance oxygen atoms by adding water. So we add the quantity of water that will make hydrogen to be that will make oxygen to be 7, just as it is at the left hand side. So it means we are simply going to add 7 moles of water. So 7 moles of water automatically has given us 7 atoms of oxygen, but it has created a problem for us. What problem is that? It has brought in 14 atoms of hydrogen. So in bringing in 7 atoms of oxygen, we have, or in other words, brought in 14 atoms of hydrogen. Somebody may ask, how 14? How? It is 14 because this 7 is for both oxygen and hydrogen. So for hydrogen, it's going to be 7 times 2, which is 14. But for hydrogen, it's just 7 times 1, which is 7. So we have brought in 7 oxygen atoms and 14 hydrogen atoms. That is just what we've done. So in the case of our reduction half cell, do we need to balance oxygen? No, we don't need to balance oxygen. So we just simply write it that way still. Now we are done with step 4. The next step is, so since we have balanced oxygen, it means we'll also have to balance hydrogen, because we have, in balancing oxygen, brought hydrogen in. So we have to balance hydrogen. So to balance hydrogen, it means we are adding protons at the left-hand side, or you may say hydrogen ions at the left-hand side. And how many hydrogen ions are we adding? 14. Since there are 14 atoms of hydrogen at the right. So we have to add 14 hydrogen atoms. Ions, I beg your pardon. 14 hydrogen ions. So we have done that now. We simply write our chromium 3 and 7 molecules of water. So our iron 2 to iron 3 remains the same. So Step 5 is done. Our next step is step 6. And by the time you know how to balance any given redox equation, you will not need to be repeating these equations like this. From one line, you can just do everything. But we are taking our time to do this so that you will get used to it and, of course, become a pro in balancing redox reactions. So, but once you are used to balancing redox reactions, you will not need to be repeating this. Just in a single line, from the very first step, you can add up everything. You can balance the other atoms other than oxygen and hydrogen. In that single equation, you can balance oxygen, balance hydrogen, balance the charges, sum them up. In fact, it will even take you more than 2 lines. That is actually how it is done here. So step 6 now is to balance the charges.